Picture this, a clear night sky far from the city lights. The heavens stretch wide above, stitched with brilliant points of light that seem to watch us back. But these lights aren't just pretty, they're cosmic furnaces, burning at millions of degrees. These lights are stars. But what is a star, really? Stars are born from something fragile: dust. In the darkest regions of space, massive clouds of gas and dust drift in silence. These clouds, called nebulae, are so large they could swallow thousands of solar systems. For millions of years, gravity pulls the material inward, slowly, patiently. The cloud contracts, the pressure rises, heat builds up, until finally something incredible happens. The core becomes hot and dense enough to ignite nuclear fusion. And in that moment, a star is born. At the heart of every star, hydrogen atoms fuse into helium. This process, nuclear fusion, releases an enormous amount of energy. That energy pushes outward, while gravity pulls inward. The result? A perfect balance. The star begins to shine. Our sun is just one of them. A fairly average yellow star, mid-sized and mid-aged. But there are stars out there that make the sun look like a candle next to a bonfire. Blue stars, hot, fast-burning giants that die young. Red dwarfs, cool and small, yet able to live for trillions of years. And then there are the titans, supergiants so massive they can swallow their own solar systems whole. They're so far away that the light we see tonight may have left those stars thousands or even millions of years ago. When we look at the stars, we're not seeing the present. We're staring deep into the past. Stars are the clocks of the universe. They mark cosmic time. They forge the elements that make up our bodies, our planets, everything. And they're still teaching us about the origin and fate of all things. Behind every star in the sky, there's a story of chaos, heat, gravity, and time. And that story is only just beginning. Not all stars are the same. Out in the cosmos, they come in every size, color, and personality. Some live for trillions of years. Others explode in just a few million. And all of that depends on one thing: the mass they're born with. Let's start small. Red dwarfs are the most common stars in the universe. Tiny, cool, and incredibly efficient. They burn their fuel slowly, so slowly in fact, they can live for up to 13 trillion years. That's nearly 1,000 times the current age of the universe. You can't see them with the naked eye, but they're everywhere. Silent, long-lived survivors. Then you've got the blue giants, massive, hot, and short-tempered. These stars live fast and die young. They burn through their hydrogen like there's no tomorrow. And when they reach the end, they go out with a bang, some collapsing into black holes, others exploding as supernovae that rip through space and time. In between these two extremes, you'll find stars like our sun, a yellow main-sequence star. Not too big, not too small. It's about halfway through its life, at 4.6 billion years old, and still has another 5 billion to go. But its fate is already written. When the sun runs out of fuel, it will expand into a red giant, growing large enough to engulf Mercury, Venus, and maybe even Earth. Then it'll shed its outer layers and collapse into a white dwarf, a dense hot remnant about the size of Earth but with nearly all of the sun's mass. And there, in silence, it will fade over billions of years, until it disappears. Massive stars face a more dramatic end. After a supernova, what's left might become a black hole, a region so dense not even light can escape. Or a neutron star, where atoms are crushed so tightly that protons and electrons merge into neutrons. Just a teaspoon of neutron star material would weigh billions of tons. But here's the twist. These stellar deaths create life. Supernovae scatter heavy elements across the galaxy: carbon, iron, oxygen, the very things that make planets, oceans, and us. We are, quite literally, made of star stuff. Every star's life is a story of fire, gravity, destruction, and rebirth. When a star dies, the universe doesn't end. It begins again. Look up at the sky on a clear night. Hundreds of points of light, stars. Some are relatively close, Others lie hundreds of light years away, but our eyes and our minds connect those dots into familiar shapes, invisible lines crossing the cosmos, telling ancient stories. Those shapes are constellations. But here's the scientific truth. Constellations aren't real groups of stars in space. They only seem close together from Earth, when in reality, many of them are separated by unimaginable distances. It's like looking at the windows of a skyscraper from the side. They appear aligned, but each one sits at a different depth. Take the constellation Orion, for example. It looks like a mighty hunter in the night sky. But the red giant Betelgeuse, marking his shoulder, is over 640 light-years away. Rigel, at his foot, is nearly 860 light-years distant. They only look near because our perspective lines them up. So why do we still use constellations? Because they serve as celestial landmarks. Astronomers divide the sky into 88 official regions, each named after a classical constellation. When we observe a galaxy or a supernova, we might say it lies in the direction of the constellation Leo. It's like using neighborhoods to navigate a city, even if the buildings inside them aren't physically connected. But constellations also carry history. Ancient civilizations used the stars to tell myths, track the seasons, and navigate across oceans. To the Greeks, they were gods and heroes frozen in the heavens. To indigenous peoples around the world, they represented animals, spiritual guides, and cycles of life. The Southern Cross, for instance, has long guided sailors in the southern hemisphere. Scorpius crawls into the summer skies, marking seasonal shifts. And in the north, Ursa Major points the way to the North Star, a timeless anchor in the sky. Each culture saw the sky differently. And while modern astronomy has standardized constellations, our fascination with them lives on, because deep down, connecting the stars is a way of making sense of the universe and ourselves. Stars don't just appear, they're born. And like any birth, it's messy, violent, and absolutely beautiful. It all begins in a mysterious region of space, a nebula. Imagine a colossal cloud of gas and dust, floating silently for millions of years. Some of these clouds are hundreds of light-years wide. One of the most famous, the Orion Nebula, is a massive stellar nursery. But a nebula alone isn't enough. To ignite the birth of stars, something has to disturb it. A shockwave from a nearby supernova, the collision with another interstellar cloud. Whatever the trigger, it causes certain regions of the nebula to collapse under their own gravity, and that's when the magic begins. As gravity pulls the gas inward, it heats up. Pressure builds. At the core of this collapsing region, a glowing ball of gas forms. This is a protostar. It doesn't shine yet, but it spins, emits infrared radiation, and keeps feeding on the surrounding material. This phase can last millions of years. Then, when the core temperature reaches about 10 million degrees Celsius, something extraordinary happens. Nuclear fusion begins. Hydrogen atoms smash together, forming helium and releasing enormous energy. That's when a star is born. It starts to shine, not by reflection, but from within. From this point on, the star finds balance. Gravity tries to pull it inward. Fusion pushes outward. This tension creates a perfect equilibrium. The star enters its most stable phase, the main sequence. It can last billions of years, depending on the star's size. Our own sun has been in this stage for more than 4.5 billion years, all of it from a cold, dark cloud floating in space. So when you look up at the night sky, remember this. Each star you see is a survivor of chaos, a flame born from dust. And when a star is born, it doesn't just shine. It transforms everything around it. In the universe, birth means transformation. Every star is a battlefield. On one side, gravity trying to crush everything into the center. On the other, nuclear fusion pushing outward with unimaginable force. This balance is what keeps a star alive. For most of its life, it stays in what's called the main sequence. During this phase, it fuses hydrogen into helium in its core. It's a violent process, but a stable one. The energy released escapes as light and heat, holding the star together. But that peace won't last forever. The fuel runs low, the core contracts, and the star begins to wobble. Some enter unstable phases, swelling, shrinking, changing brightness. These are variable stars, warning signs that something big is coming. These pulses aren't random. They reveal the star's interior, like seismic waves through a planet. It's like listening to the heartbeat of a giant, and when the core can no longer sustain fusion, the end draws near. Every star is born to shine, but none escape their end. When the core's fuel runs out, the balance breaks. Gravity wins, and the star's fate depends on its mass. If the star is small like the sun, it becomes a red giant. Its core contracts, while the outer layers expand and cool, turning red. In the end, these outer layers are expelled as a colorful nebula, a planetary nebula. What remains is a dense core, the size of Earth, called a white dwarf. It no longer shines through fusion, but by residual heat. One day, it will become a black dwarf, cold and invisible. Larger stars meet a far more dramatic end. When the core collapses, the result is a colossal explosion, a supernova. In seconds, the star releases more energy than the sun will in its entire life. This explosion creates the universe's heaviest elements: iron, gold, uranium. What remains can be even more extreme. If the mass is high, a neutron star forms, matter so dense that a spoonful weighs billions of tons. But if the mass is colossal, nothing can stop the collapse. Not even light escapes. A black hole is born, a point in space where the laws of physics no longer work. A silent abyss that swallows everything around it, even the star that created it. And this is how a star dies. But part of it always continues. In planets, in people, in every atom of iron in your blood, we are made of stardust, literally. The night sky has always fascinated humanity. What we see are patterns, constellations, created by our minds as we try to connect stars into familiar shapes. Constellations are not actual structures in space. They're simply groups of stars that appear to be close together from our perspective, but are often separated by vast distances. It's like connecting dots on a canvas. Yet what we see carries deep meaning. Constellations have names that span across cultures and history. In Greek mythology, for example, we have Orion, the hunter. In modern astronomy, constellations are official regions of the sky used to help locate stars and celestial objects. Each of these regions tells a story. One of the most famous is the Southern Cross, a vital symbol for navigation, especially in the southern hemisphere. It's one of the most visible constellations and serves as a celestial compass. To ancient navigators, the sky was a map. Each star and constellation pointed the way. These patterns helped guide humans across unknown seas and distant lands. Today, constellations remain a way to explore the sky. Modern astronomy uses precise coordinates, but constellations still carry a special power. They connect science to culture, to myth, to history, and above all, to our sense of wonder. If the universe fascinates you like it does us, hit that subscribe button now. Here on Nebula Verse, the journey never ends, and the next destinations are already locked in. Tap the bell, leave a like, and tell us in the comments which star blows your mind the most. See you in the next video.